Hi class, this is Dr. Karsten, and today we are doing lesson 38, and that's from Module 5, Grade 4, EngageNY Math. So today's lesson is pretty much a repeat of yesterday's lesson. We are once again going to be multiplying a whole number times a mixed number. But before we get started, I wanted to review from a few lessons ago how we multiply a whole number times a fraction. I'm going to apologize in advance. This is actually my third time starting this video because the puppy has been incredibly rambunctious. He just had a nice long nap while I was doing other work. And now I took him out and he should be fine. He just had dinner. So I'm apologizing in advance that he is just in a really rambunctious mood today. So if he interrupts us, I might have to pause a few times, so I apologize in advance. So back to this lesson though. Before we get started in doing our proper lesson of multiplying a whole number times a mixed number, I want to review how we multiply a whole number times a fraction. So for example, if I wanted to multiply 4 times 3/5, there were a couple of different ways that we were working on this. I'm not going to go through the whole reason why we do it these ways, because that was a couple lessons ago, and you can always go back and watch those videos again. But I just wanted to review the actual what you guys have been doing. There were two ways that most of you were comfortable with multiplying this. So one way, when we have 4 times 3/5, was to say that you have 4 times 3/5. And remember this, we just did the associative property to group them the way we wanted them. And when we do this now, we can say that we have 4 times 3, which is 12/5. Now, the other way that we worked on doing this was to say to ourselves that if we were doing 4 times 3/5, to remind ourselves that the denominator is telling us the number of pieces or parts that make up one whole. So in this case, when we have a 5 down here, we know that one whole has been cut up or partitioned into 5 equal-sized pieces, and we have 3 of them. When we're talking about a whole number, such as 4, what we know is that the whole has not been cut up at all. The whole is still one whole piece. That's why it's 4 wholes. They're whole pieces. They're wholes. So what we now can do is simply say, let's multiply our numerators, 4 times 3, which is 12, and we can multiply our denominators, 1 times 5, which is 5. So those were the two ways that we could multiply 4 times 3/5. These are the two ways that we really settled on. All right, so now that we've looked at that, let's jump into the proper lesson. So again, today's lesson is very similar to yesterday's. We are going to continue multiplying a whole number times a mixed number. So let's start. So let's do 2 times 3 and 1/4. So if I'm multiplying 2 times 3 and 1/4, another way of thinking about this is to say that I have 3 and 1/4 2 times. So I could actually go ahead and draw a tape diagram and model 3 and 1/4 2 times. So let's go ahead and do that. So I'm going to start by modeling the 3 wholes. So here we have 3 wholes, and I'm just going to put a 3. So instead of doing all 3 wholes separately, I'm just going to mark off 3 wholes. Then I'm going to do 1/4. So right now, I have modeled 3 and 1/4 one time. So we have 3 and 1/4. Now let's go ahead and do it another time, so we'll have it 2 times. So I'm again going to draw 3 wholes. And now I'm going to, let me write that, and then I'm going to add on that 1/4. So now I have drawn 3 and 1/4 2 times, and I can go ahead and show it again, that I have 3 and a 4. So I have 3 and 1/4 2 times, 1 time, 2 time. And I'm thinking that most of you are going to be able to say to me, well, I can just go ahead and add my 2 3s to get 6. So let's write that. And then I can add my 2 fractions. 1/4 plus 1/4 is 2/4. So let's go ahead and write that. So what we are showing here is that we have 6 and 2/4 by combining our whole numbers and then combining our fractions. Now though, wouldn't it be a lot easier if we could actually have our whole numbers next to each other and just count up by threes or count all our whole numbers together and then have our fractions together so that we can count up our fractions together? And we are allowed to do that. When we're multiplying or adding, we are allowed to move things around. That was the commutative property. So I'm going to go ahead and switch this 3 and this 1/4, switch their places, just to show you what I'm talking about. Because when you start multiplying really big numbers, it's going to be helpful to think about it that way. So first I'm going to draw the 3 that we have. Then I'm going to draw this other 3. So far I drew the 1, 3. Now I'm going to draw the other 3. So now we have our 2 3s. So we really have 3 2 times here. See, I have 1 3, another 3, 3 1 time, 3 2 times. So this is really 3 2 times. And now I'm going to draw this 4th. And then I'm going to draw this 4th. So now what you're seeing is that I have 3 2 times and I have 1/4 2 times. I had that up here too. I just now put them into I grouped them. So I have my whole numbers and my fractions together. So another way of writing this would be to say that I have 3 2 times. And another way of writing this would be to say that I have 1/4 2 times, or 2 times 1/4. So I'm hoping that this is ringing a bell from yesterday's lesson where we showed that we could do the distributive property. And what we were doing was, instead of multiplying 2 times 3 1/4, we would multiply the 2 times the 3, which we have right here, and then we would multiply the 2 times the 1/4, which we have right here. So we're modeling this 2 times 3 1/4 by using the distributive property and pulling that apart. So when we did that, remember that we want to show that these are being grouped together still. And that's to prevent from any confusion with what we're supposed to be doing, the order of our operations. And then remember that when we want to combine all these things, another way of thinking about that is that we're adding them all together. We're adding 3 plus 3, so we're adding 3 2 times. And then we're adding 1/4 plus 1/4, so we're adding 1/4 2 times. And then we can add all that together. And so what we end up with is 2 times 3, which is 6. And then we have 2 times 1/4, which is going to be 2/4, just like we did before. Now when we get to this point, we can simply say that we have 6 plus 2/4. Another way of saying that is 6 and 2/4. So we have 6 and 2/4. So this is the distributive property. For now, for the next problem, I'm going to again work it through the same sort of way. But if you're feeling really comfortable, again, you can just start saying, well, I have 2 times 3, which is 6, and you could jot that down. And then I have 2 times 1/4, which is 2/4. Again, if you're feeling really comfortable, you can go ahead and do that. So let's do another problem in a similar way to this one before we start moving into other problems. Just trying to find the top of my page here. All right, so let's try another problem. Let's keep the numbers simple again. Let's do 3 times 2 and 2/5. So 3 times 2 and 2/5. So now again, if you are already feeling really comfortable with this, you could say, well, again, I have 3 times 2, and I would go ahead and put my 6 down, and then I'd say I have 3 times 2/5, and if you remember your ways of doing that, you'd say 3 times 2 is 6, and you'd end up with 6/5. Now the only difference is with this one, you would have to take this fraction greater than 1 and turn it into a mixed number, and we're going to get to that in a minute. But I did want to show you that at this point, you might be comfortable enough to just do it in your head this way. But if you're not, again, what we can do is we can distribute this. So I'm not going to draw the whole thing out again this time. If you need that modeled for you again, you can go and rewind and take a look again about how I drew it. But we're going to jump ahead and we're going to say we're doing 3 times 2 and 3 times 2/5. You know what? Maybe it would be helpful for us to model it. So let's show this. So we'll do it both ways. So I'm going to be a little quicker. So now this time we're going to have 2 2/5 two times. So I'm going to have 2 2/5. So that's one time. And then I'm going to have another 2 2/5. So that's 2 times that I've drawn this. And I'm just reiterating this, making sure you really see it. And then we're going to do it one more time because we have to do it 3 times. We have to do 2 2/5 3 times. So I'm going to draw 2 2/5 one more time. And what I'm hoping that you're seeing is that we have 2 2/5 one time, 2 times, 3 times, but we could also go ahead and group our whole numbers together, our 2 plus 2 plus 2, and we could group our fractions together, 2/5 plus 2/5 plus 2/5. So let me model that. So here's our first 2. Now I'm going to put our second 2 right next to it. And then I'm going to put our third 2 right next to that. So now we have 2, 2, 2, but we have them next to each other. And now let's put our 3 fractions here, 2/5, 2/5, and 2/5 next to each other. So we have 2/5, 2/5, and 2/5. So again, we have the same exact stuff, we've just ordered them in a different way. This is a way that's going to make it easier to do the math. So what this represents is 3 times 2, because we have 2 3 times. So 3 times 2. I have the number 2, and I have it 3 times. And then over here, we have 2/5, and we also have that 3 times. Because what we just did was we distributed. We took that 3, and we multiplied it times the 2, and then we multiplied it times the 2/5. This is, in essence, what distributing is all about, the distributive property. So let me go ahead and let me rewrite our fraction here. So we have 3 times 2 2/5, our number sentence. So again, I want to distribute this. I want to do 3 times 2, and then I also want to do 3 times 2/5. So if I were to write this out, I could do it in my head again like we did before, but I'm going to write it out right now. I have 3 times 2, and again, we can just combine all of this, right? Here were our fractions, and we can add them. So I'm going to redo that down here. So I'm going to do 3 times 2, put it in parentheses, and then I'm going to add 3 times 2/5. Now, another reason that you can do this, I just want to remind you, is that when you have 2 2/5, another way of writing that and is to say plus. 2 2/5, but then you have to put that parentheses there to show that that's really one number together. And it's also telling us what to do first. It's telling us that this has to be distributed across. Okay, so now let's solve this. 3 times 2 is 6 plus, and again, 3 times 2, and remember we have those 2 different ways we could do it. We could do 3 times 2 over 5, or we could say 3 wholes times 2/5. And either way, we're going to get the same answer, which is going to be 6/5. So let's put that here. So we have a problem. We really don't want to end up with a fraction greater than 1. I know this is a fraction greater than 1 because my numerator is bigger than my denominator. Our rule for this problem, we look at the denominator, our rule is going to be that 5/5 is equal to 1. Oops, you can't really see that. Let me rewrite that. That 5/5 is equal to 1. That's going to be our rule. The rule is based on the denominator. So what I want to do is I want to pull out groups of 5/5 from this. So I could go ahead and I can pull out 5/5. So that's 1 whole. We know that from our rule. And that would leave me with 1/5 left. I had 6/5. I put 5 here. I have 1 there. So I had 6 pieces, 5 pieces there, 1 piece there. Remember now that this becomes 1 1/5, and we still have our 6 being added to that. We could say 6 plus 1 is 7. I'm going off the frame a little. and we still have our 1/5. So we just combine 6 and 1 is 7, and we have our 1/5 right there. And that's our answer for this problem. Okay, I'm going to do one more example before we go into the problem set. And the next example is, we're not going to do a drawing, we're not going to do a tape diagram anymore. So let's go ahead and jump into that. Give me a fresh piece of paper, there we go. Let's try, I don't know, let's do 4 times 9 and 3/4. So again, let me remind you that another way of thinking about 9 and 3/4 is to actually write 9 plus 3/4. But we want to show that this is still one piece, and that whatever happens to it has to happen to both parts of that piece. So we have 9 and 3/4. And that is all going to get multiplied times 4. So again, I'm going to have 9 4 times, and I'm going to have the 3/4, the fraction 3/4 4 times. So I could do 9 plus 9 plus 9 plus 9 plus 9, or I could do 3/4 plus 3/4 plus 3/4 plus 3/4. Either way, it's going to work for both of those. And the reason is because we're going to distribute that 4 across. So we're going to say 4 times 9, and then we're also going to do 4 times 3/4. So we're going to do the same thing for both of those. So let's write that. So I'm going to actually use this now to emphasize. So we're going to do 4 times 9. Put that in parentheses. And then remember, we're adding stuff together. We're combining it. That's because we have the addition symbol right there. And then we're going to do 4 times 3/4. And now I can go ahead and add those numbers. So this will give me my whole number right here. 4 times 9 is, oh, you know what, I want to switch back to the black. 4 times 9 is 36 plus, and then we have 4 times 3/4. So 4, and remember we have the two different ways. So we could do 4 times 3 over 4, or we could say 4 times 3/4, and this is 4 ones. Either way, we're going to get the same answer. We're going to get 12/4. Now, if I want to combine these, the smartest way for me to do that is to realize that I have a fraction greater than 1 because 12 is bigger than 4. And now I want to pull out groups of 4/4. Why 4/4? Because I have 4 in the denominator. So my rule for this one is going to be that 1 is equal to 4/4. Oops, I'll do it this way. So let me pull out one set of 4/4. So I had 12 pieces, I put 4 there. Let me put another 4 here, so now we're up to 8. And now let me put another 4 here. So now we're actually up to 12 whole pieces. Sorry, 12/4. And that's like saying 1 whole plus 1 whole plus 1 whole. So let me go ahead and jot that for us. So this actually becomes 3 wholes. So we have 36 plus 3 wholes, which is 39. All right, so again, what we did was we kind of pulled apart or decomposed the 9 and 3/4 so that you had your whole number and your fraction. Then we took the other whole number and multiplied it times each piece there. So here we had the 4 times the 9, here we had 4 times 3/4, and then we were able to convert this and add them all together. All right, so now let's jump into the problem set. I'm just going to pause you while I get my papers. And I'm back, and it's like magic, right? In a snap. Okay, so again, we're doing lesson 38. We're doing the problem set. So let's take a look at the first one here. And they're saying, fill in the unknown factors. So if I take a look at this, I can see that I am distributing 7. So I'm going to do 7 times 3, and then 7 times 4/5. So what I can see here is that the missing factor is 7. 7 times 3 and 7 times 4/5. So I'm going to let you work on the next one. All right, so here we go. For number 2, it says multiply, use the distributive property. So if I'm going to be multiplying using distributive property, what I'm going to do is I'm going to multiply 7 times 8 and then 7 times 2/5. So the first step that is always really helpful is to pull this apart. So we're going to say 7 times. Now you still have to show that they were at one time together. 8 2/5. And now I can distribute that 7 across those. So I can do 7 times 8 plus 7 times 3/5, or 2/5, sorry. And now I just have to multiply. So 7 times 8 is 56, plus 7 times 2 is 14, so 14/5. Oh, but we have another problem. We have a fraction greater than 1. So I'm just going to pull this, well, I guess I'm going to pull this up here to work on. So we have 56 plus 14/5. So for this problem, 5 is in the denominator. So we know that our rule is going to be that 1 whole is equal to 5/5. So I want to pull out groups of 5/5 out of this. So I'm going to have 5/5. So I had 14 pieces. I put 5 here. Now another 5/5, which gets us up to 10. If I put another 5/5, I'm going to be at 15. It's going to be too big. So instead, if we put 4/5, we're going to have 5, 10, 14. And that is perfect. And then remember that this is equal to 1 whole. We know that over here, that this is equal to 1 whole. So that's 1 and 1 is 2, and 4/5. And let's keep our 56. So 56 plus 2 is 58, and 4/5. All right, so I hope that this is starting to make a little bit more sense to you. You guys are actually going to finish out the rest of problem 2 as part of your homework. And I just want to mention to you that when you see it like this, you can actually just flip it. The the commutative property of multiplication says that we can reverse this order in multiplication. So that's the problem that you can do. All right, and let's take a peek over at 3. So I don't want you to panic over, let me just preview this. Don't panic over this. It's the same thing, just flip them. Okay, so and then you have 2 word problems. So I think we're probably good. And I just realized I don't think I ever gave you the secret code words again for today because I got distracted so much with the puppy. So I don't even know where I left off with that. So for all of you lucky ones who are here at the end, here's the entire phrase. So the entire phrase is we're, W-E'-R-E, so like we're almost, A-L-M-O-S-T, done, D-O-N-E. So we're almost done. We're almost done with the whole module and with the school year. It's almost summertime. So we're almost done. So that's your code for today. Anyway, have a great day. I will see you in our Google Classroom. We're wrapping things up. I'm so excited. We have some great projects we're doing. I can't wait to see all your hard work. And I'll see you in our Google Classroom. Have a great day.